help answer questions.
I'm Dan Roth. I'm product manager on the ASP.NET Core team. I work specifically on Blazor and our web UI frameworks like MVC and Razor Pages.
I am Jeremy Lickness. I'm product manager for ASP.NET Core backend, so I get to drive the data through APIs to the Blazor apps that Dan was talking about.
And I'm Mike Kistler. I'm also a product manager in the ASP.NET Core team. New to the team, actually, since last December, so happy to be here. I'm working mostly on SignalR and Orleans, but also helping in other cloud-native areas.
Hello, everyone. I'm Artak, the engineering manager on the Blazor team.
Awesome. Okay, so I think we're going to start on Jeremy's screen, correct?
That's the plan.
Yes, I have it queued up.
Okay.
All right.
So here's
all those lovely people that you just got introduced to. I think Aditya wasn't able to make it today, but we have Safia here to represent on that side. So today the plan is to talk about what's coming, what's happening for ASP.NET Core, for web developers in .NET 9. We're already in the throes of this. We just shipped .NET 9 Preview 2 early this week. That's what John was showing. So features are already starting to come off the conveyor belt into your hands to try out and give feedback on. But we're going to go do a broad overview of the roadmap of everything we're planning to do for this release, and answer questions and take any feedback that you have on our current plans. So for .NET 9 and ASP.NET Core, a big theme for this release is just general quality and fundamentals. So think security, performance, observability, just making sure that everything gets faster, everything runs better across the stack. We're doing more work on APIs to improve our API story, make sure they're nice and introspectable so you can have great tooling around your APIs. Some work on validation. We'll talk about all the details on each of these items in just a minute. On the runtime side, work on distributed caching, data protection, and more work on authentication that we started in .NET 8. Telemetry and metrics, of course, are really important for all those cloud-native workloads, like having great observability. So we have a bunch of work planned around making sure your ASP.NET Core apps show up really well in like that Aspire dashboard where you're looking at your distributed traces, looking at your metrics. And then, of course, for people building web UIs, we have lots of improvements planned on the Blazor front. Now, you can find all of the details on the ASP.NET Core roadmap on GitHub at aka.ms/ASP.NET/roadmap. That's where you'll find the full listing of all the GitHub issues, tracking all these items. Subject to change, of course, as we progress through the release. We find out, some things take longer than we expected or other priorities come up that we need to adjust. So, you can find the latest data at that link as well. We update that roadmap as the release progresses. But this is our current thinking about what we're expecting to do for the release. And we're going to start with Jeremy, who's going to start telling us about the work we're planning to do for APIs.
Okay, yeah, I'll dive right into that. It's a little bit misleading because I think you only got one bullet, Dan, but you've got a lot of Blazor improvements, so we'll get to that as well. But let's talk about APIs in .NET 9. And so there's two key things that we're focusing on. The first is a built-in open API generation. So that's actually producing the document as part of the process in the box shipped with ASP.NET Core. There is a discussion on GitHub, and we can grab the link and link out to that. I'll post it in chat or something around that. But we've got a design discussion open so that developers out there interested in open API generation can talk with us, tell us what features you're interested in, what's important to you. I'll give you an example. So we're very focused on the JSON schema generation, but there are other formats you can use, such as YAML. And so we've heard from some individuals that they're using that in their workflow. So we take that feedback and build it into what we're doing with the roadmap. The other piece of this is built-in support for model validation. So this closes the loop on being able to use the APIs to do things like pull in your annotations and rules and validations and models, and is also useful for what we're planning and mapping out with AOT and being able to build capabilities into that. So moving on, I distributed cache and hybrid cache. So we provided some capabilities in previous version, and we've got our report card here, repetitive and error prone, verbose and complex with limited features. And so what we're bringing out is the hybrid cache improvements that is focused on simplicity, just working in most cases, providing you with the advanced options that you can dial into when needed. And then we've got some of these enhanced features that we can dive into more details of as needed. The stampede protection. I don't know if you knew that stampeding was an issue, but there is protection for that. Tagging and validation, L1, L2 in process, out of process support, and much more. And the important thing to note is that all of the existing cache backends will keep working, so we're not breaking with this. And I'm going to, I guess I can't advance the slide here, so we'll advance it here. So data protection is something else that is developers run into this, especially when you have a distributed workload, which is something that we've been focused on with the Aspire, and it's still blowing my mind that we're in March, so we're already a quarter into building this out. But basically, if you're using anti-forgery and if you're using authentication, data protection is something that factors into it, and it's a set of libraries that help with some of the, I guess, cryptography and other aspects of that. And the defaults work great for single instance apps when they're tied to a single machine. But when you get to a distributed environment, there can be challenges. And so part of this focus is providing a way to make it easier for you to use data protection in those distributed environments, because we know that's what people are using and moving to. And so that default experience needs to improve. And so that's what the data protection pieces are about. Moving forward, authentication. So we tackled authentication in the previous release. We looked at a very specific use case for those of you who are standing up applications that need some self-contained authentication. But we also recognize that there are third-party authentication providers, and we have our own intra provider that has the capabilities to scale out through the organization and have different applications authenticate with each other, plug into OIDC workflows and OAuth and et cetera. So what we want to do for you is provide those intra-related samples with the new Blazor web app. So the issue is we've had the prior templates that were based on Blazor server, and we had the WebAssembly, but we have these new rendering models and interactivity models, and we need to update the samples to work with those. And once those are updated so that you have those, the other aspect of this is we can then work with our tooling teams to provide you with the capabilities to scaffold and use connected services to configure connection strings and basically take your existing applications and plug this into it. So we recognize that a lot of the times authentication is something you add into a project, and so we want to make that streamlined for you. When we talk about more and better samples, this is continuing to work on different cases, whether it's a combination of application types, whether you're using a front-end JavaScript framework, et cetera. We want to have those samples for you to know how to plug in authentication, and quite frankly, a straightforward authentication where you're using one type of provider is a pretty well documented story. But when you start to use multiple authentication schemes or maybe a different provider based on context or the user, et cetera, it can get more complicated. So we want to have those samples for you to reference and see how to do that. And finally, the pending documentation items. So we believe that a big part of authentication, we've heard the feedback from you that sometimes we have good documentation, but it can be difficult to find. And landing on the right level of documentation is key. And so one of the examples of what we're doing documentation-wide is providing what I call a navigator document, which is sort of the choose your own adventure. So you tell us what you're interested in. Are you new to authentication? You need to learn about it. Are you just looking at how to implement it with .NET? Are you working on a mobile application? And the goal of the document will be to guide you to the right documentation that gives you the samples, the tutorials, the how-to, and the information you need to be successful with that. And so we'll be taking that on for this release as well. Telemetry and metrics. This is so important to see what's going on with your applications. And we began that story in .NET 8. We're going to be extending those metrics. We have the low-level Kestrel metrics. We have the feature to exclude requests, Blazor and Blazor server telemetry, so you can see what's going on with those applications, this new hybrid cache I talked about, and then support tracing implicitly in ASP.NET. So taking out that extra step of a dependency and pulling in a package, but making it part of what we ship. And then this isn't if we have time, as Dan mentioned earlier. You know, these aren't commitments, these are goals and that we're working towards, but we very much understand the importance of getting quality telemetry from authentication, authorization, identity. And so that is going to be a focus. It's prioritized behind some other items, but we hope we have time to get to that and drive that. Now, all of this is happening on the back end. This is how your services are presenting data, pulling data, exposing data, communicating data, etc. But once you take that on the front end and start to do something with it, that's where you get into Blazor territory. And for that, I'm going to turn it over to Blazor's PM, Dan.
Thanks, Jeremy. Okay, cool. Yeah, that all sounds great. So what's happening then for web UI development? Trying to get some pixels on the screen. What's happening for Blazor? Well, .NET 8 obviously was a very ambitious release for Blazor. In .NET 8, which shipped back in just this past November, we introduced tons of new features for Blazor, new render modes that you can choose even at runtime. We added static server-side rendering capabilities and also advanced progressive enhancements on top. So you can really use Blazor now for all of your web UI needs. No matter what type of web UI architecture you want to build, Blazor now supports those scenarios. And it's really now our recommended solution for building web UI with .NET. MVC and Razor Pages are still great and still fully supported. But if you're building a new project and you want to have all the flexibility and all the new capabilities available to you, Blazor is honestly where it's at. In .NET 9, we're going to take some time to really focus on the quality of those features and improving the developer experience with using them. So .NET 9 is going to be a much more quality-focused release for Blazor, less transformative. So quality and fundamentals is top for us in the .NET 9 release for Blazor, including work on performance, security, and observability. We know from user feedback that there are some rough points with how the new Blazor web app features compose or integrate with each other. So we're going to do work to smooth out the user experiences with Blazor web apps and fill in some of those user experience gaps. We are going to do some targeted work for Blazor server applications or for interactive server rendering to address some long-standing issues, improve performance and also improve the experience with disconnects or reconnection. We have ongoing investment in Blazor WebAssembly as well, so we're going to continue to invest in the .NET WebAssembly runtime and also look to do performance work on the load time of Blazor WebAssembly-based applications. And then lastly, we have a bucket of work to improve the general developer experience for Blazor, improvements to tooling, and to Blazor's component model. And I'll go through each of these in some detail. So let's first talk about Blazor web apps in .NET 9. So like I said, based on feedback, we know there's some areas where Blazor web apps could use some improvements. The first is performance. Performance is a big part of everything we do in .NET, but we really didn't get enough time in .NET 8 to do all the performance tuning that we wanted to on the new static server-side rendering support in Blazor. So we're going to take some time in .NET 9 to do that, to make sure you get as much throughput as possible when doing static server-side rendering. We also plan to make it possible to statically render a page when you're already in an interactive context. And what does that mean? Well, today with .NET 8, we already have the ability to do the opposite. Like you start rendering a page, you can start rendering a page statically. You get a request, you start rendering some HTML, but then you want to add some interactivity like in just one part of the page. In .NET 8, you can decorate an interactive render mode on a specific component or even on a whole page and light up interactivity for just that part of the app. But what you can't do really well is the opposite, where if you've decided, you know what, I really want most of my app, globally, I want my app to be interactive. Oh, but there's this one page or just this one set of pages that I want to be rendered statically. It's possible to do with .NET 8, but it's not very clean. In .NET 9, we're going to make sure that you can go from an interactive context, like an app that you've set up to be globally interactive, and be able to render pages statically from within that application. This will be for both when doing page navigations and also when dealing with the response to a request from an interactive form. Like if you have an interactive form and you just want the response to be a normal post and get the rendered response. Okay, so using static server-side rendering from interactive context is the second one. Detecting the current render mode. Sometimes when you're building a component, you want to adjust what that component renders based on how it's on what its current render mode is. For example, you might want to render interactive UI elements as disabled when you're doing pre-rendering, which is like static rendering, but it's going to become interactive later. Or you might want to render a completely different UI elements when interactivity isn't available. We're going to add APIs in .NET 9 so you can detect the current render mode and adjust your component rendering logic accordingly. So detect the current render mode APIs. All right, persisting component state with enhanced navigation. In .NET 8, we made a change to Blazor when you're using the Blazor web app model to always pre-render your pages. So they're statically rendered initially and then set up for interactivity on the client. That way you get pixels on the screen as fast as possible. When you're doing pre-rendering and your component is initializing any state, particularly asynchronously, like maybe you're going off to and calling an API and getting some data, or you're doing a database query. If you're doing pre-rendering and you have that type of component, you end up with this problem where you acquire the state on the server so you can pre-render, and great, shows up immediately to the user. But then when the component gets set up for interactivity, it needs to acquire that state again. Otherwise, you can end up with these like flashing situations where you see all the data that was nicely pre-rendered, but then the component renders interactively and it's like, hold on, I got to go get the data again. And so it, wipes out all the data that was just shown and shows a loading ... or some sort of loading spinner again. And then the data comes back. So you see data, then no data, then data. And the way you can fix that is we have a feature where you can persist the state that was used during pre-rendering so it can be reused on the client. And we have an API that allows you to access that persisted data. Unfortunately, it doesn't currently work with the enhanced navigation pattern where Blazor intercepts when you're doing a page navigation and you're getting the data from the server. So we're going to fix that in .NET 9 so that persistent component state works also with enhanced navigations. Because this pattern of using persistent component state is also now becoming more common, we're also going to do some work to add a declarative model for handling that persistent component state. Instead of you having to write a bunch of code to save the state and then check to see if it's there and extract it out, we're going to give you a declarative way where you can define some properties, annotate them, and say, you know what, I've got some persistent component state that I want here in this property. Please save it for me so I can access it later. And that should make dealing with that component state easier. We think this work also accrues to a longer-term investment with being able to persist circuit state, like when you're using Blazor server or doing interactive server rendering. That state normally just stays in memory, and if the circuit goes away, it's lost. We think this declarative model will also give us a way in the future, post.NET 9, to be able to save and rehydrate circuit state so that your interactive server components are also more resilient. So that's what we're doing for Blazor web apps. For Blazor server apps, or when you're using interactive server rendering, we also have some improvements planned. We've already enabled WebSocket message compression in .NET 9. This takes the payloads that get sent over the WebSocket connection when you're doing interactive server rendering and runs compression on them, so they're much smaller, so they're faster to transfer, and you use less network. That's on by default now with .NET 9 Preview 2. So if you're using .NET 9 Preview 2, you should already be seeing that benefit. We're going to do some work to improve the observability of Blazor server apps. Today, when you're looking at the distributed traces for interactive server rendering, you basically just see this one long WebSocket connection request, and you don't really get any visibility to what's happening inside that connection, like all the UI events that are occurring or rendering. We're going to add distributed tracing activities to Blazor server so that you get more visibility into what's happening in your interactive server rendered Blazor apps. And then lastly, we know there's some pain points around the reconnection user experience when using interactive server rendering. Interactive server rendering is a stateful connected model. In order for the UI to work, you've got to have that WebSocket connection with the server. And if anything happens to the circuit, then there's nothing that will automatically save that state and reestablish it for you. And so often users end up in your end users of your app can end up in a disconnected state where they have to manually refresh the browser and they lose whatever they were doing. We want to improve that user experience. So we're going to start some reconnection logic improvements in .NET 9. And I was going to show you a quick early prototype of what that might look like. So let me pop over here to my desktop machine and we'll do a quick demo. So this is a Blazor server based application. And what I'm going to do, I'm just going to go ahead and run it. I'm going to run it from the command line, and that's because I don't want Visual Studio jumping in and refreshing the browser for me when I'm starting the app. I want to try and simulate what really happens with this app during production. So let's just go ahead and do, actually that's the wrong one. That was it. So this and .NET run to get this up and going. And we'll take a look at what the default experience is with Blazor just to understand the problem here. Okay, so here is a Blazor server app, and we've got a little form. We've got a button that we can click, like a counter, and then we have some fields in a form. We can add some data in here, and we can see this form is interactive. All that stuff is working, and we're able to adjust the rendering of this form as I type in stuff. So cool demo, and voila. Okay, so we've got a form. I've been filling it out, and let's imagine that something happens to the app where the user gets disconnected from the server. In this case, I'm going to simulate that by actually shutting the server down. I'm just going to Control-C, server's down. And then what do we get? Oh, we get the dreaded white screen of death, right? Like the user's now in a disconnected state, and by default, Blazor puts an overlay over the whole screen to let the user know, hey, the UI isn't going to be working right now. And it's letting the user know that it's trying to reconnect to the server. And this is kind of honestly, it's a cool feature that's being shown here. If it was just a transient network connection, Blazor will hold on to the circuit state on the server for a little while the client tries to get back to that state and says, well, maybe I just went in a tunnel or whatever, and if I can just reconnect, then everything will be good. Now in this case, obviously, the server is completely down and the circuit state is gone. So even if I bring back up the server, let's run the app again to say the server is now up. We should be able to at least connect on the network. Now, first thing to notice is server's up, but it's still saying it's trying to connect, and that's because there's a fairly long reconnection delay with each time it tries to reconnect. I think it's like 20 seconds by default. You can change that, but the default is pretty long, which isn't great for your end users. But eventually, if I talk long enough, there it goes. It will say, oh, the server's back. Oh, but darn, my circuit is gone. Like the state that I used to have is no longer present because the server went completely down. And sorry, user, the only thing you can do now is refresh the page. And Blazor doesn't do that for the user. It asks the user to do that manually. So, I can click here, refresh the page. And of course, now on my form, everything that I was doing, my counter is gone. All the form fields that I filled in, they get lost. The user basically has to restart. So that's not great. That's the current reconnection experience with Blazor server. We'd like to try to do a little bit better. So let's do this. I'm going to shut this down again, and I'm going to make a change. And this is a prototype that Steve Sanderson put together, actually. It was last year, and this is public on GitHub. You can find this on his GitHub account. And I'm just going to add this little stateful reconnection component here, and we'll restart to see if we can have a better experience. So I'm going to run this again. Let that build. And then see if we can do a little bit better. So there's a couple of tweaks that that we're looking at doing. One is, can we have at least a better UX for when the connection gets lost? So here we are back, same functionality as before. Can add some text boxes, check some check boxes and whatever. And now if I shut down the server, let's simulate the loss of connection again. Okay, new fancier UI, so it's not just overlaying the whole screen with a whitewash. It's slightly better user experience. Also, if I bring the server back up, let's see, there that goes. Okay, so the server's back up, and almost immediately the app gets back into a functional state for the user. We reduced in this prototype the reconnection interval to just 1 second, so it's much more responsive. And you'll notice that even though the circuit was lost in this this demo, I don't end up on a broken screen. Actually, I'm seeing the application. So we automatically are refreshing the page for the user, so the user doesn't have to click the button. And you can do that manually yourself today with .NET 8 or earlier releases, but in this prototype, we decided, maybe we should just start doing that for you. And you'll notice that actually a bunch of the form state, like all the form fields that I had started messing around with, they got rehydrated. Like it persisted some client state for me and repopulated the form. Now, you may also notice that, with the server-side state, like the value of the counter, that still gets lost. So this prototype doesn't do anything to try to persist server state and rehydrate it. That's something, like I said earlier, that we are looking to provide help and mechanisms to make that easier. For .NET 9, we're still expecting that will be something you'll have to handle in your app yourself. Like there's ways you can do it. In .NET, post .NET 9, we hope to make it simpler to do. But for server-side state, this doesn't help. But for client-side state, faster, reconnection for the user, automatically refreshing the browser, hopefully these are some user experience improvements that will make people using your Blazor server apps happier. So that's what we're looking at doing there.
Hey, Dan, we got a question. How does it save that state? Is that it's just client-side?
Client-side state's being persisted in local storage in the browser, and then the Blazor server script. The Blazor script is like identifying, I have some state here that I can repopulate into the app.
Okay. One other question is, can you tell on the server side if the client's disconnected?
Yes. In fact, the server knows when it has a circuit and the client is gone, it knows that, and that's why there's this thing that the server does, right? Like it will actually hold on to the circuit state for a little while and saying, well, maybe the client will come back. You don't want to hold on to that state necessarily indefinitely, because then you end up in a potentially a DOS like situation where people keep opening up connections and then closing the connection, and now you've got all these circuits that are building up. So they will eventually time out. The default timeout, I believe, is about 3 minutes. You can extend that if you're in your environment. It makes sense to hold on to those circuits longer, or make it shorter if you want. But yeah, the server knows if the connection is gone.
Cool.
All right.
And one last question. You didn't have to do anything to wire that up to local storage? That's just kind of magically handled for you? Right?
That was in the prototype. It's magically handled. Now we're still working through the exact details of what we'll ship in .NET 9. Like these are some experimental ideas that we're playing around with. That's why we're sharing them with folks to see what people think. The model around dealing with the client-side state is certainly an interesting set of problems. How much we can do there, how much do we save, how can you participate in that process. We'll be working through those set of design problems as part of the .NET 9 release.
Cool.
All right, cool. So that's better Blazor server reconnection, and that's the set of Blazor server items we're planning to do. What about Blazor WebAssembly? What if you're doing things purely client-side? So we're doing a bunch of work for WebAssembly-based rendering as well. The first thing is we're going to start, and this is actually kind of a broader than just Blazor WebAssembly. For your static web assets, we're looking to start fingerprinting those assets with a hash of the content of the file that actually becomes part of the file name. And this is like a build step. As you're building your app, we take your static web assets, your JavaScript files and so forth, and we fingerprint them so that they have a unique file name. And this is useful for a number of reasons. With Blazor WebAssembly, the way the caching works, we really want a consistent set of files that get downloaded to the browser and run. And Blazor will carefully check. Like it actually has a manifest. There's this like blazor.boot.json file that has a kind of a list of all the static web assets that make up at least the client part of the app, with hashes to make sure that it knows, okay, these are all the files that should be used together. And if it downloads all the files and finds that the hashes don't match, then you can end up with these integrity check failures, like letting you know, like, hey, you've only got like part of the app here. Some of it is potentially stale. Normally that shouldn't happen. Like normally you of course publish your whole Blazor WebAssembly app in one go, and you have a nice consistent set of files. But due to some environments, you might still end up with some inconsistencies. Like maybe you're using a CDN and all the files haven't propagated everywhere, so you end up with some staleness. Or maybe something gets cached by like a CDN and it's just stale and hasn't been updated, and people end up seeing these errors when they're trying to update their Blazor WebAssembly apps. So to avoid those integrity check failure problems, we think this fingerprinting technique will make your deployments much more robust. They're also useful for helping us optimize the page load time and the startup time of your Blazor WebAssembly apps. We're going to do a bunch of optimizations in .NET 9 to help your Blazor WebAssembly apps load faster, and also just to make any static web assets in ASP.NET Core that you're downloading download faster. So this is sort of a summary of all those optimizations we're doing. So aggressive caching, now that we've got like a fingerprinted file with, static content, we can aggressively cache that file, tell the browser, download this once and you don't need to ever download it again, to make sure that your apps load quickly. We also will do work during development to make sure that your files are always fresh, so you don't end up with stale files while you're trying to develop locally on your machine when you're making changes and you want to see the latest. Pre-compression, this is a trick that we already do for Blazor WebAssembly apps, but only for some of the files, like for the runtime and the assemblies that make up the code of your application. When you publish, we run broadly pre-compression on those files to shrink them down as much as possible so that the amount you have to transfer over the wire is smaller. In .NET 9, we're going to expand that pre-compression support to basically all static web assets. So even JavaScript files, CSS files, basically anything that's not already compressed. Like you don't want to do this on a already compressed image or video, that sort of thing, or fonts. But anything that's not already compressed, we will support pre-compressing those files so that they're smaller to download. Bundling and this is really about the bundling of the JavaScript assets that we ship in Blazor. Some of them are, blazor.web.js is not a small file. We're looking at, using more modern bundling techniques to shrink that size of that file down as much as possible. Preloading, we're planning to do work to generate link tags so that you can preload static web assets when we know that you're eventually going to need them. This will avoid you having like a cascade of requests where you have to like wait for, you request blazor.boot.json. Now you know all the files to download, so you request all those, and you have this sort of cascade that happens. By using link tags, we can preload content so you kind of get everything all at once, thanks to the help of the browser and the web platform. And then lastly, doing optimization on our startup performance. One of the things we learned from doing the new auto render mode, which really optimized the download time for the .NET WebAssembly runtime, is that there's still actually quite a bit of time that gets spent, even once it's cached, to get it up and running. Like just starting the .NET WebAssembly runtime takes a little bit of time. Running Blazor's initialization logic takes some time. And that's why you can still sometimes see a delay, even if you're using the auto render mode and you've already downloaded and cached the app. We're going to do work in .NET 9 to shrink that part of the load time down so that it's faster. So your Blazor WebAssembly apps load faster. Okay. And then the last one for WebAssembly is multithreading. We've been working on multithreading for a long time. I think it's currently still our top voted feature request for Blazor is to support multithreading on the WebAssembly runtime. And we have made really good progress. Like our friends on the runtime team have got pretty much all of their test suite now passing on the .NET WebAssembly runtime, which is amazing. The remaining work is actually on the Blazor side. We have some cases in Blazor WebAssembly where we assume a single threaded runtime that we need to now clean up and make sure that it will function properly in a multi-threaded runtime. But to show that we actually have made progress on this feature, and you saw the tentative there. We don't think this is actually going to be ready for production use in .NET 9, but we hope to at least have it available in full preview support so you can use it with your Blazor apps. But to show you that what the current state of things is, let's close down this app, and I'm going to open up a multi-threading app. So this is actually with .NET 9 Preview 2, like using the bits that we just shipped earlier this week, and I turned on the multi-threaded runtime for this app. And the way you can do that is you just set WASM enable threads true in the client project. That will say, client project, I want you to use the multi-threaded runtime, not the single-threaded one. And then there's one other thing you need to do. To use multi-threading, you actually, multi-threading is implemented using some fairly powerful browser features. It uses shared array buffers under the covers. And in order to use shared array buffers in a browser, you actually need to put it in what's called a cross-origin isolation state, which basically says, don't allow like cross-origin communication with like other frames or windows with this application. I wanted to isolate it to just the origin really that it came from. And so there are some headers that you have to specify when loading this app in order to make shared array buffers and multi-threading work. We did a little bit of work to help you set those up. So when you're adding your interactive WebAssembly render mode, we have this new API that's served the multi-threading headers. You just set that to true, and that will put the browser in cross-origin isolation state. Things that this will affect, like if you have a pop-up that's a cross-origin pop-up in your app, then this will prevent it from interacting with the original app. And that can break things like federated auth flows that are using pop-ups, or like some payment patterns also. I think we use a cross-origin pop-up this way. So something to be aware of. Multi-threading inherently, just because of the way the web platform works, requires this constraint. But once you've done that, we should now be able to run this application. And this is a normal Blazor app. I've got the counter page here where I have the normal counter button that I can click and the count goes up. But I added this start thread button where I can actually create new threads. If we look at the counter, here's the code. Second button right here. And it's got this start thread event handler for on click. When I call start thread, we're just doing a task.run. And this is just going to loop 5 times and do have a 1 second delay, and then call invoke async to increment the count, and then call state as change so that it renders. So this should start a thread that basically increments the count every second. Okay. So if I click on start thread, then we should see the counter start to increment on its own. And if I mash on this a little bit, it should increment faster because now I've got multiple threads that are incrementing the current count. So that's working. It's cool. Like, this is something you actually can start trying out. Unfortunately, there are a bunch of known issues. Like if I show what, set your expectations appropriately. Like if I browse to another page right now, then the .NET WebAssembly runtime throws an exception because Blazor's doing something synchronous with a synchronous JavaScript interrupt call, and that can create deadlocks. And so we need to clean up Blazor's logic to make it work properly fully in this multi-threaded world. But that's where we're currently at. So tentatively for .NET 9, we hope that this will be available at least in preview form in your Blazor apps. All right, so that's multi-threading. All right, lastly, improved developer experience. These are just some, general improvements to the Blazor's component model and also to like the tooling and experience. So we just added in .NET 9 Preview 2 support for constructor injection in Blazor components. I don't know, it was Mr. Magoo. I saw Mr. Magoo on the chat, I think briefly. I think this was his GitHub issue that he opened a long time ago. And we finally got it done. It's, again, a highly upvoted item. This means you can inject services into your Blazor components using the standard constructor pattern, in addition to the existing, @inject property-based service injection pattern. So both will continue to be supported, but now you can use constructors with your Blazor components. Adding metrics for Blazor across the board. We did a bunch of metrics in .NET 8. We haven't, and it was mostly at the lower levels of the stack, like at the runtime layer, Kestrel and those types of things. In .NET 9, we're going to start adding metrics into Blazor, so you can see like how many active circuits you have and those types of things. We continue to work on hot reload to have support more edit types, to be faster and be more reliable. On the tooling side for Razor editing, the Razor tooling team is very hard at work in conjunction with the Roslyn team, doing performance work, reliability work, and correctness, so that you always get good and accurate completions, and that the tooling is fast and stable. And then also we have been adding Blazor scaffolding so that you can scaffold out your Blazor components. And I have a quick update on that I'll show you. We just shipped the Blazor CRUD scaffolder in Visual Studio 17.9. So you can now take an Entity Framework core model and scaffold out a bunch of pages. In 17.10, we now have in preview the Blazor Identity Scaffolder. So you can scaffold the identity code into your existing Blazor web apps. And we're looking to add also a scaffolder that will just allow you to enable Blazor in your ASP.NET Core app. Like if you're not using Blazor yet, but you want to turn it on, like maybe side by side with your MVC code or your Razor Pages code, giving you a scaffolder that makes that easy. And I'll show you just real quick what that looks like. So if we hop back into Visual Studio, let's just create a new project, Blazor web app. That looks good. .NET. This works with .NET 8 as well, so it's not tied to .NET 9. We'll just keep all the defaults for this Blazor web app. And I didn't select the individual user accounts option, so I don't have any auth in this app yet. But now I decide, I want to add it. Darn, do I have to do file new project again? No, we can just scaffold it in. So I'm going to do right click on the project and add a new scaffolded item. And then if we go under identity, now you can see we have the new Blazor identity scaffolder. So I can select that. And if I have an identity DB context, I could just pick it. I don't believe I currently do. So yeah, no, I have one. So I just go ahead and create one. So add that. We can pick which database provider we want. We can create a custom user class. I'll just select the defaults for those. And then you sit back, and this is the wonderful thing about scaffolding, right? You just sit back and let Visual Studio figure out all the code to write for all this stuff. The login page, logout pages, user profile pages, all the ability to do multi-factor authentication and so on. Just going to add out that code for me into the existing project. Again, this is with you need the Visual Studio preview channel to try this out, but it is public. You can do this yourself. And after this finishes generating, there we go. So if you look over here in the account folder, we've now got all the pages for the default Blazor Identity UI. I do need to run migrations in order to run this. Let me just do that real quick. So I'm just going to bring up I like to do this from the command prompt. Great. I'm going to do .NET EF migrations, add initial, I guess, would be fine. Give it a name. And what this is just doing is this is just looking at the schema for the database that you want, and then you can update the database with that schema so that the database is ready to go when you run the app. If you don't do this, then when Identity tries to connect to the database, it'll be like, well, there's no database here. So .NET update database will then run some SQL to set up the database for me, and then we can see the app in action. What is it? The database. Copy. Reverse my parameters there. Then we should see some SQL spew. There it is. Okay, so now I should be able to run this. And then if we bring up the browser, we can see all the normal identity pages are now here, and I can register a new user. Register a new user, pick a dummy password for demo purposes, and then register that, and that should work fine. That will send it into the database. This is just a little dev UI for confirming the email account, and now I should be able to log in with that new account. So easy to now add Blazor Identity to an existing app without you having to copy a bunch of code over from the templates. There, we're logged in, got all the user profile information as well. And you could run the CRUD scaffolder on this as well to add some data based off of your EF core models. That all now is fully shipped and supported. But I think we've shown that before, so I'll skip that demo.
So I'm holding most of the questions and comments till later, but there were a few that are scaffold related that I thought I'd throw up there. So
yeah, do it. Let's
question here, can you run the scaffold CLI for non-Visual Studio users?
Yes. So the scaffolding engine does have a CLI experience for running the scaffolders from the command line. So yeah, you can do that. I mean, it's a little harder because you have more parameters to pass in, like all those things that I'm specifying in the nice wizards, like which DB context do you want to use? Do you want a custom user type? What database provider do you want to use? You have to specify all those on the command line, but they are runnable from the command line as well, and the cross-platform. Like you can run them on the, on your Mac or your Linux machine.
Cool. Let me see. So one here about scaffolding from a Swagger file to generate Blazor API or app from an API.
Oh, like something that takes an API schema and then generates some UI for that data. That's kind of interesting. It's kind of like analogous to the EF Core data model, but instead using the API as sort of your data model. Yeah, that's cool. One thing I know that the scaffolding team is working on is the extensibility model for the scaffolding to improve it so that it's much easier for you to write your own custom scaffolders that can then plug into Visual Studio and be usable from the command line. So that might be something that I know they're working on that for the current 17.10 release. So I would expect to see, hopefully I haven't overpromised them, but I know they've been working on it. Hopefully that will come out, and then you can try out the new extensibility model to build something like that. We don't have that one in our plans, but we can certainly talk about and consider doing it.
Awesome. Okay.
Great idea. Love that. Okay, quickly on Blazor Hybrid for all you native client app developers out there. The big thing we're doing for hybrid development is we're going to put together a solution template so that it's easier to set up both Blazor Hybrid and web. Like if you want mobile, desktop, and web, today you have to create both projects and kind of stitch them together with a Razor class library. We are working on a template to just make that easy to do and make sure it follows all the best practices with the new render modes that we added in .NET 8. There's also a bunch of just general .NET MAUI improvements that will accrue to Blazor Hybrid developers, better hot reload support in MAUI, a bunch of improvements coming for desktop development, like WebView 2 drag and drop, I know is something we've been working on with the WebView 2 team, and better Windows publishing, and of course the Visual Studio Code tooling, the new MAUI extension for Visual Studio Code. I know there's also a big documentation effort just to make it easier to figure out how to do some of the more common scenarios with Blazor Hybrid apps that the MAUI folks are also working on. All right, so that is all the Blazor stuff, and that's the entire .NET 9 roadmap for ASP.NET Core. Again, all the details are at akms/ASP.NET/roadmap. We also have public discussions already in place in GitHub discussions on the ASP.NET Core repo for discussing the roadmap or asking questions. But we were going to take the rest of the time to hear what folks on the call would like to talk about. Any feedback you have or any questions you have about the roadmap, we're happy to answer them. We got everyone here to hopefully got all the subject matter experts involved to cover all the topics. I'll leave this slide up.
So I starred some, and then folks watching, if you want to star any other ones, and then people watching live, this is your chance. Give us your feedback. If your question didn't get, feel free to ask it again if we miss it. Okay, so question here, distributed caching, are you planning to handle disk-backed caching?
I am not the expert on distributed caching, but as far as I'm aware from the implementation, it provides abstractions for swapping out what you're backing.
Disconnected out.
We
first renders.
Toolkit are
really helpful for.
If we don't get to everyone, like their progress trying to use Razor
to wrap it up, and you've got your ending slide here. We've got a link to the roadmap,
and the roadmap itself has the discussion link in it. So if you're looking for discussion and you remember the roadmap, you'll find it that way.
Perfect.
But let's see if I can quickly do a thing here. That's the one. You see that?
Yep. This is great. Okay,
I hot reloaded it into my PowerPoint presentation.
Very, very nice. Okay, I think this is awesome. And then, of course, we'll have more deeper dive